The cost in millions of dollars to manufacture X 100,000 units of a product per month is given in the table. Here we have a table with an X row in terms of 100,000 units and cost in millions. We're asked to create a scatter plot of the data in the table. All right, so let's bring up our calculator and go to our stat and edit, and let's clear out some old stuff. All right, so list 1 had 0 through 10. All right, and list 2 is the cost, so 5.4, 7.7, 8.65, 9.38, 10, 10.54, 11.03, 11.49, 11.91, 12.3, and 12.67. All right, so considering the data, 0, go a little bit less than 0, a little bit more than 10 on the window. So let's go from, how about -1 to 11 by ones. And for the y values, it starts at the minimum value is 5.4 and the maximum value is 12.67. Let's go a little bit less than 5.4. So I'm going to go all the way to 0 because I like to see where the 0 is. And I'm going to go up to, how about 15 and a scale of 1. All right, let me go to my y equals screen. Okay, turn the plot 1 on by moving up to it and hitting enter. And that should cover L1 versus L2 and hit the graph. All right, and we see some data here. All right, and our data does not appear to be linear. Notice especially, let me drag this over here. Notice especially, this point right here. If it wasn't for that point, we might consider a linear function, but that point's way off of the line, as it seems. All right, so there's our scatter plot. Now we're told that an estimated model for this data is given by the following. Let C, so there's some notation there. Let C of X be the cost in millions of dollars to produce X 100,000 units per month. We're told C of X is 2.3 times the square root of X plus 5.4. Let's graph the model with the data. All right, so bring our calculator back up and to the y equals screen. 2.3, and your square root button is the second function of the x squared key on the left-hand side. Type your x, close it off, and then plus 5.4. All right, let's graph it. And I'll drag it over here. All right, so that looks like a really good model. Okay, notice how it even sort of hits that lower point. All right, that 0, 5.4 that we said would make a linear model less reasonable, and it comes very close to all of the other points. This looks like a very good model. Estimate the cost to produce 1.5 million units per month. So here we have to be careful. Remember, X was in terms of 100,000. It was the number of 100,000 units. So 1.5 million is 1,500,000. So X was in terms of 100,000 units. So 1.5 million, 1,500,000 would mean that X is equal to 15. So then c of 15 would be 2.3 times the square root of 15 plus 5.4. 2.3 times the square root of 15 plus 5.4 is approximately 14.31. So the cost to produce 1.5 million units is $14.31 million. If this company produces up to 2 million units per month, find the domain and range for this function. All right, so again, up to 2 million units. 2 million units is the same as saying x is equal to 20. So therefore the domain would be from 0 to 20. Now as for the range, let's go back to the function. Let's go back to the graph and see what happens if we substitute 20. We don't have to even use the graph. We can just change that 15 out with a 20 in the function. And so what we see is f of 20 is 15.68. We see from the graph that the function is increasing, so we don't have to worry about it going any higher or any lower than sort of the boundary points we've already defined. So then the range, the minimum value that we saw was 5.4. The maximum value is 15.68 approximately. So what we'll do is we'll round that up a little bit to 15.7. Use the graph to estimate the number of units the company can produce with a budget of $15 million. All right, so thinking about it, if the budget is $15 million, we need to find x, so that c of x is 15. All right, so there's a couple approaches to this. We could trace along the curve. So what I did there, when I hit the trace key, it put me on the points. It put me on the lists, the data points. If I move down, if I press the down button, now it's on the Y1. And I can just sort of trace along the curve until it gets to 15. That might take a while. And in fact, it's outside of what we set in the range in the window. So let's change the window and let's change the x max to 20 and regraph it. And we should probably change our y values, our y maximum. We set the y maximum to 15.7, so let's just go up to 16 there. All right, and retracing. Oh, and pressing down. So we want the y value to be 15. Looking for the output to be 15. So 17.31, 17.54, somewhere around there. I'm sorry, 17.5. Now, so that's one way. Another way is to go back in your y equals screen. Let's turn the plot off and put in the y2 value of 15. Now that'll give us y equals 15, which is a horizontal line. And now what we can do is calculate that point of intersection. So I went to the calc menu, intersect command, then scroll near the point of intersection, get reasonably close, hit enter 3 times. And what I see in that graph is that they intersect when x is approximately 17.4. 17.42, about 17 and a half, which is pretty much the same thing that I found just by tracing along. So going with that intersection, that x value of the intersection, what that tells me is the company can produce now 17.4 hundred thousands. So about 1.74 million, I'm sorry, 1.74 million units with a budget of $15 million.